This is what the vertex form of a quadratic equation looks like. We know it's going to be a parabola, alright? Quadratic equations, squared, going to be a parabola. This is vertex form. So this video is all about graphing a quadratic equation when you are given vertex form like this. The first step is to identify the vertex. Now the vertex comes from these two numbers, okay? And this is going to tell you your vertex, and it's going to be the opposite of this one, comma that one. So your vertex is going to be positive 4, comma 8. All right, that's what they mean up here when we have minus h and then k, and then they tell you the vertex is h and k. Well, this minus in the formula is telling you that's the opposite of this one, and this plus is telling you just to keep this one the same. Opposite of this one stays the same. Okay, anyway, so now we got the vertex. So you're going to want to put the vertex in the middle of your table of values. So this will be 4, comma 8. With that in mind, the lesser x values will be 3 and 2. The greater x values will be 5 and 6. Alright, from that point, I would suggest let's consult the TI-30 XS multiview. Let's see, so we have negative 2 times the quantity x minus 4 squared. Let me write that much. That's all I can remember at one time. Okay, so negative 2 times the quantity x minus 4 quantity squared plus 8. So plus 8. I'm going to wind up hitting enter 5 times. 1, 2, 3, 4, 5. Okay, so here we are. Our chart starts off with an x value of 2. So let's scroll up. Well, scroll down. Let's scroll down to that 2. Okay, so it's 2 comma 0. So I have 0, 6, 8. So I've got 0, 6, and we already knew the middle would be 8. Okay, now you can bet that the other two values are going to be 6 and 0 because of the symmetry of a parabola. These are going to be equal and these are going to be equal. But let's check and see. So as I scroll down, 6 and 0 just like we thought. Okay, now we can plot these points. So I have 2 comma 0. That's genius. 2 comma 0, 3 comma 6, 4 comma 8, and then the symmetry kicks in with your 5 comma 6 and your 6 comma 0. I'm curious if the next point will fit. 7, negative 10, just barely, but it fits. So I recommend that you always do what I just did. Look and see if other values will fit. So in this case we have 7 comma negative 10. If it will fit on your graph, use it. Alright, it doesn't cost you anything. And that means we can bet that the point 1 comma negative 10, because of the symmetry, will also be on the graph. It'll just make your graph more exact. Alright, let's go ahead and draw this. Alright, I'm going to cheat and use my Microsoft Word features. Okay, you do what kind of bootleg process you need to do. Okay, so there we go. I'm liking green for this. Alright, so there's a nice parabola. Now, what do we need to know about it? Okay, so let's start filling in some information. The vertex, well, we knew that right from the very beginning. That was 4 comma 8. Let's go ahead and fill that in now. Is this vertex a maximum or a minimum? Well, you see that the vertex is here at the very top, so that makes it a maximum. Clearly the parabola is turning down. Alright, you can look at these like arms reaching down, so this is down. And the axis of symmetry, is going to be a vertical line right down the middle of this parabola. Okay, so here's your axis of symmetry, and the vertical lines are always x equals a number. So because this vertical line is at 4, then the axis of symmetry is x equals 4. Okay, so let's record that. X equals 4. Don't just put 4. It's got to be x equals 4. Now the zeros are the x-intercepts. So the x-intercepts are here and here. 2, 0 and 6, 0. Alright, the zeros and the x-intercepts are basically the same thing. Now the y-intercept, that's the place where the parabola touches the y-axis. Now we come all the way down to here and the parabola has not touched the y-axis yet. Does that mean there is no y-intercept? No, for a parabola there will always be a y-intercept because this keeps getting wider as you go down. So what I would recommend to you is understand that the y-intercept of course is going to be 0, something. Because that y-intercept is going to be on the y-axis wherever it is. So the x value will be 0. So to find the number, the y value, let's use a calculator. So let's scroll to 0, an x value of 0, and see what we've got. So 4, 3, 2, 1, 0. Bam! Well, no wonder it didn't fit on the graphs because it says 0, negative 24. But that is the y-intercept. Just use your calculator to help you find it. So 0, negative 24. Now the domain, as usual, the domain is going to be negative infinity to positive infinity. Because the domain is the x values of a graph. And these x values go left and right forever. The domain represents the y values of a graph, and you have to give it to me in the order from bottom to top. At the bottom you see that this goes down forever, so the range is going to start with negative infinity. But does it go up forever? No, it has a ceiling right here. It doesn't go past 8, so it'll be negative infinity to 8. And we'll put a square bracket to show that 8 is included on the parabola. Okay, so that's it for number 1. Yep, that would be too easy. Sorry, I was talking to my kid, guys. So on problem number 2, the vertex is going to be the opposite of this one, that one. So the opposite of this, vertex is going to be positive 3 and then negative 2. Opposite of this, that. So let's put that in the middle of our chart. 3, negative 2. Now, as far as the x values, lower than 3, so 2, 1. Greater than 3, so 4, 5. Alright, let's put this thing in our TI-30 XS multi-view. 2 times the quantity x minus 3 squared. Okay, 2 times the quantity x minus 3 squared minus 2. Okay, kabam. I'm going to hit enter 5 times. 1, 2, 3, 4, 5. My chart here is going to start with an x value of 1. So I'm going to scroll until that happens. So I've got 6, 0, negative 2. So 6, 0, and oh look, the negative 2 that we already knew. Now, because of the symmetry of a parabola, I know that these y values, because here's where it starts going back up again, so 0 and 6. Now let's just verify. Oh look, 0 and 6, just like we knew. Let's graph these points, guys. 1, 6 would be right there. 2, 0, it's on the line. 3, negative 2. And then the symmetry, 4, 0, and 5, 6. Let's check and see if the next value would fit on the graph or not. 6, 16, nope, that's off the graph. So we'll make do with these. We're going to play these. Alright, let's go ahead and graph the parabola. Okay, so there's a nice graph of our parabola. Please, when you draw it, make sure you draw the parabola going all the way to the edge of your graph. Okay, now as we've decided, the vertex is 3, negative 2. Is this vertex a maximum or a minimum? Well, you see how the vertex is sitting here at the bottom of the graph. It's the lowest point. It is a minimum. Okay, this graph faces up. So I'm going to put up. By the way, you should be able to tell just by looking at the equation if the parabola is going to face up or down. And it's all about the leading coefficient here. See how that 2 is positive? Because it's positive, it's going to be facing up. Okay, on the previous problem, we had a negative number in the front. This a value is negative, and therefore we knew the parabola would be facing down. So just keep that in mind. Okay, the axis of symmetry is a vertical line right down the middle. Alright, so there's your axis of symmetry. Now, this is a vertical line at 3, so that means the axis of symmetry is the line x equals 3. Don't just put 3, we're talking about a line. This line is the line x equals 3. The zeros are the x-intercepts, and they are here and here, so that's 2, 0 and 4, 0. Alright, now the y-intercept is where the graph touches the y-axis. It's not visible here on the graph, it's just off camera, if you will. It's not on the chart, so we will get it off the calculator. The y-intercept is always 0, something. So just scroll to 0 and take a look. So 0, 16, and that's why we didn't see it, because 16 is too high for this graph. But the calculator handles it just fine. So the y-intercept is 0, 16. The domain, that's the x values. In other words, how far to the left and how far to the right this parabola goes. Well, parabolas like this go to the left forever and to the right forever. So the domain is going to be negative infinity, positive infinity. Make sure you give them the round parentheses. Now the range, that's the y values of a graph. So that's how low it goes and how high it goes, in that order. So what's the lowest value on this graph? Lowest value is here at negative 2. Okay, and then it goes up forever. So we're going to say negative 2 to infinity. Now infinities always get the round. Now we're going to use a square bracket on the negative 2 to show that, kabam, the graph hits negative 2. Negative 2 is included as part of the parabola. Okay, in fact, you can see that negative 2 right here in the vertex, 3, negative 2. Alright, so the square bracket means the negative 2. Alright,